Welcome back for week 5, day 2. This is Mrs. Siebers again, and today we will be talking about modeling and solving multi-step equations. Let's go ahead and take a look at the solutions to your homework problems from yesterday.
Hi, and welcome to week 5. Today's objective, we will be solving algebraic expressions. I am Ms. Shawn Newkirk, the Title I Math Coach and Math Department Chair at Albert Hill Middle School, and I will be going over your homework solutions with you for the week. For question number 1, it says provide the algebraic sentence that would represent 10 less than 2/3 of a number. So when we're looking at this question, we have to remember that we're writing it in not necessarily the order that we see it in words, but what it means to actually be able to solve a statement. This one says 10 less than 2/3 of a number, which means I'm taking 10 away from whatever the 2/3 of the number is. That is the way that I need to write it. So the first thing that I need to write is 2/3. And then I have the next part of a number. And when you do not know the actual value of the number, you represent that particular quantity using a variable. So for this one, we will use an X. Coming back to this part, it says 10 less than. So we know that this less than is represented by a subtraction sign with the quantity of 10. For question number 2 for week 1, it says provide the verbal expression that would represent the algebraic expression. There are several ways that you can write this one, but this one can also be written straightforward, which is what we're going to do today. We notice that a coefficient outside of a quantity represents, or quantity in parentheses represents multiplication. So we're going to write it as such. 2 times, and actually, we need to write it out in words. So it should be 2 times the difference of a number and 3 increased by 7. Okay, so we have 2 times the difference, because we're taking the difference of a number and 3, increase, which is our addition sign, increased by 7.
So those are your homework solutions from day 1's work. Today's objective, you are going to represent and solve equations using Algebra Tiles. Today you will need paper, your pencil, and you will also need 2 different coloring utensils. So it can be crayons, markers, colored pencils. We will be using red and yellow, but if you do not have red and yellow, any 2 colors will work. Just again, here's your vocabulary that we talked about yesterday: solving multi-step equations, solution to an equation, and then your properties of equality that we talked about earlier this year when we did order of operations as well. And those are those same pictorial representations that we talked about yesterday. Let's go ahead and take a look at our instructional videos for today. This first video is just an introduction to Algebra Tiles.
Hey, this is Mr. Field. I'm going to give you an introduction to Algebra Tiles today. We're going to use these a lot throughout the year to help us represent different algebraic expressions and equations. These are really useful all the way up through late Algebra 1 as far as representing everything that we'll be doing from then on. And they'll really help most students get a good understanding of algebraic concepts that gave us adults so much trouble back in the day. Now what we have is 3 different algebra tiles. They're colored on one side and they're red on the other. They're each red on the other side to indicate negative numbers. We're going to start with the little yellow square. Now all of this is based on an area model. So if we look at the area of this square, we're going to agree that the length of this square is 1 unit long. And since it's a square, that means that the width of it is also 1 unit long. And we all remember from years ago that the area of a square is just like the area of a rectangle. It's length times width. In this case, we have a square with an area of 1. So from now on, we're going to use this little yellow square to represent 1. And as I said earlier, a red one will be -1. Okay? Now we're going to pull out the little green rectangle. Notice that it has the same width as the square. It is 1 unit wide. However, if we try to measure the length of it, we'll find that we really can't come up with a good answer for how long it is. It doesn't line up perfectly like that. And so what we find is we don't really know the length of this. And so we can imagine this green rectangle as sort of a magic box that contains an unknown number. Could be 1,000,000, could be 0, could be 3, we don't know. But we're going to call this length x, which is usually what we use in mathematics to represent an unknown number. So we have a rectangle here with an area of x times 1, length times width, and that is x. So from now on, this green rectangle is x. And, as you might have imagined, this, whatever x is the opposite of it. We call that -x. So it doesn't matter if x is 1,000,000, this is -1,000,000. It doesn't matter if x is 3, this is -3. It doesn't matter if x is 0, this is 0 is its own opposite, so this is also 0. So whatever x is, this is going to represent the opposite of it. Okay? Now, we have another piece here that we won't use at all in 7th grade math. But if you'll notice, this square is x units long on one side and x units long on the other side. And x times x is x to the second power, or x squared. We also have -x squared. We're not going to use either one of those in any of the upcoming videos. These come much later as we start factoring and multiplying with polynomials and binomials and algebra. Okay, so these are gone. Now, what we can use, and this is very useful for middle schoolers, what we have here is 1 plus -1. Now, we should have already learned in 6th grade and years before that any number plus its opposite is 0. We can look at this on a number line and see if we have -1 and we add 1, that means we go to the right 1 space, and 1 space to the right of -1 is 0. So let's all just agree for now that 1 plus -1 is 0, and we're going to call a little yellow and red pair like this from now on a 0 pair. And there are several ways to show 0. This is 0. It's just 2 plus -2. This is 0. This is 3 plus -3. And even with our x's, we can show zeros. Any number plus its opposite, these are 0 pairs. That's important for us later because anytime we add or subtract 0 from something, it stays the same. So that's the beginning of the algebra tiles and 0 pairs.
Let's go ahead and look at our second video here. Here we're going to talk about solving two-step equations with algebra tiles.
To solve an equation like 3x plus 2 equals 8, model 3x plus 2 on one side of an equals sign and 8 on the other. To isolate the variable x on one side, start by adding 2 negative unit tiles to both sides and removing 0 pairs. To isolate x from the equation, 3x equals 6, divide each side into 3 rows and distribute the tiles equally. With an x isolated on each row, there are 2 positive tiles on each side opposite the variable. So x equals 2 is a solution to the equation 3x plus 2 equals 8.
All right, and we have one more video to take a look at, so we'll go ahead and do that now.
In this video, I want to use the Illuminations website to show you how to use an interactive tool to help you solve equations with variables on both sides. Now, what this tool allows us to do is it allows us to drag algebra tiles in so that we can represent the equations using a model, and then it'll allow us to help solve for the unknown variable x. So some of the options along the side here allow us to change from both our tabs from positive to negative algebra tiles. And it's going to be handy because we're going to need to change our x here in a little bit. But if I'm building the left-hand side of the equation, I like to turn my tiles vertically like this. So I'm going to have two x's, and I'm going to be taking away 4. So I'm going to change these positive ones to negative ones. I'm going to drag in 4 of these tiles here. And my left-hand side of the equation is done. Since I'm in the negatives, I'm just going to drag a negative x in to represent this, and one negative 1 counter tile for this. Now I can check to see if my model is correct by clicking this sign here, so I'm going to check it. And since I was successful, the x icon popped up here, so now I can begin solving for my x variable now that my model is built. So what I want to do is use the idea of 0 pairs to begin isolating for x. So the one thing that I'd like to do is get rid of one of the x variables on my one side. So I'm going to change these back to positive. I'm going to add 1 x tile to the right. Now by doing this, I've made my equation unbalanced. In order to keep it balanced, I've got to add 1 extra tile to the left side. Now what that did was it affected the right-hand side of the equation. By adding this 0 pair in, it cancels out both of these tiles. I'm going to do the same principle, except instead of the x variable, I'm going to be adding in some of the 1 counters. So I'm going to create 0 pairs, 4 0 pairs with these tiles here. And to keep it balanced, add 4 pairs or 4 1 tiles over here. Now, what that did was that created a 0 pair here, which eliminates these two, and 4 0 pairs on the left-hand side. So what it looks like to me is that I've got 3 x's on my left. Let me see if I can turn them, if that allows me to do that. Drag them now. So I've got 3 x's and I've got 3 1 tiles, which to me says that each x gets 1 or x is 1. We can check to see if our solution is right. It is not right, because I haven't isolated it fully. Now that I got rid of all of the other x's and I just have 1 x equaling 1, my equation is fully isolated and I've solved for x.
Let's move on to looking at our independent practice problems for today. Example 1 here says, look at the model of an equation. What is the solution to the equation represented in the model? So it's very important here that you pay close attention to the key. Your key here says that the bar represents x. Your dark colored squares represent +1, and the light colored squares represent -1. So here you're just writing what the equation is saying, and then you're going to solve it. So go ahead and pause the video here and take a moment to do that. Now let's go ahead and take a look at our solution.
Welcome back to day 2. Today we'll be solving equations with the use of algebra tiles. I do have algebra tiles here, but I decided that I would color along with you with yellow and red, or any other 2 colors that you have. Just make sure you color code in the same way. 1 color is positive and 1 color is negative. That way you can see what it would look like when you're solving it on a piece of paper versus actually using the manipulatives. All right, so this is example number 1. I have my key over here. So my yellow rectangle is going to represent positive variable. I'm going to use x. My red rectangle is a negative variable or negative x. The yellow square is going to be a positive 1 and the red square will be negative 1. So here's my problem. I have 2 positive x's. They gave us 2 negative 1s was equal to 6 positive 1s. All right, so we need to solve. Whenever we're solving an equation, whether we're doing it with models or we're solving algebraically, we want to isolate the variable. So we want to get a single positive variable by itself. So 1x or 1m or 1n. All right, so I want to see what is attached to that. I don't really care about what's over here as long as I get my variable by itself. So what's attached is a second variable. All right, I have 2 of those x's, and I have negative 2. First, we always want to undo the constant. So to undo negative 2, we're going to need positive 2. So I'm going to add 2 positive 1s to the left side. And because we're working with an equation, we need to keep it balanced. So whatever I do to the left side of the equation, I also need to do to the right. So I'm going to add 2 positive 1s to the right as well. From there, we need to see if we can create any 0 pairs. So remember from the videos, the 0 pairs are 1 negative with 1 positive. All right, so I can cancel out 2 negative 1s with 2 positive 1s. Those are called 0 pairs. So what's left is 2 positive x's and 8 positive 1s. Now, we're not done because I have more than 1 positive variable. So I need to figure out what each one of these is equal to. So I'm going to flip these variable x's on the side to help show passing out what is on the right. Bring down my equal sign. Okay, so we have 2 x's left on the left side, and on the right side, we have 8 positive 1s. So I need to split them up to figure out what each of these x's is equal to. So I have 8 total, so I'm going to pass them out evenly. So I'm going to give 1 positive 1 to the first x, 1 to the second. And I'm going to keep going until I've passed out all 8. If you're getting behind with drawing the models, just pause the video and then continue. All right, so I've passed out all 8 of my positive 1s, and what I'm left with is that each x is equal to 1, 2, 3, 4 positive 1s. So x equals 4. Each one of my x's equals 4. So my final answer is x, and you could stand this x back up now if you wanted to, is equal to 4.
Great, let's take a look at example 2. Example 2 asks you to model and solve the equation using the algebra tiles. So here, all we want you to do is draw using your colored pencils or crayons or markers. If you don't have red and yellow, you can choose different colors for your positive and negatives. And once you have modeled that, you can go ahead and solve using your 0 pairs like we talked about. And now if you're ready to check your work, you can go ahead and watch our solution video here for example 2.
All right, let's look at the answer for example number 2. Again, I have my same key. Yellow is positive, red is negative. Okay, so first we have negative 2x. So that is 2 negative x's. So each negative x is a red rectangle. So I'm going to need 2 red rectangles. So there's my negative 2x plus 7. That's 7 positive 1s. So I'm going to need 7 yellow squares. All right. Then we have plus 5x. So that's 5 positive x's. So I'm going to need 5 yellow rectangles. Remember, I'm a math teacher, not an art teacher. It's not an art contest. All right, so there's my 5 positive x's. It's equal to, so I'm going to bring down my equal sign, positive 10. So that's 10 positive 1. So I'm going to need 10 of my yellow squares. All right, so there's my positive 10. All right, so if we can create 0 pairs, we should always try to create 0 pairs first. All right, so here I do not have a 0 pair between positive 1 and negative 1, but I do have 0 pairs created between my variables. So I can cancel out 2 negative x's with 2 positive x's. So negative 2x plus 2x is 0. So I'm going to take these and cancel them, and these and cancel them. All right, so on my left side, what I could cancel is 2 negative x's and 2 positive x's. Then here is what's left. On the right side, we cannot cancel anything. It's all positive. All right, so we're going to bring down what we have left. So on the left side, I have 3 positive x's. All right, and I have 7 positive 1s left. All right, and that is equal to, we still have all 10 positive 1s on the right side. All right, so now we need to continue trying to get the variable by itself. All right, so what's attached to my one single variable was 2 more of the x's and 7 positive 1s. So first I'm going to get rid of those constants. So the opposite of positive 7 is negative 7. So I need to add 7 negatives to the left side of my equation in order to get those away from my variables to meet our goal of getting the variable by itself. And because it's an equation, what I do to one side, I must do to the other. So I also need to add 7 negatives to the right side. All right. Then, whenever we can, we're going to create 0 pairs. So positive 7 and negative 7, that's 0. And here we can also create zero pairs on the right side of the equation. So I have 10 positives and 7 negatives. So I can cancel out 7 negatives with 7 positives. Positive 7 plus negative 7 is 0. So what we have left is positive 3x equals 3. All right, so here I need to figure out how many is each of these variables equal to. So I'm going to flip my variables on their sides. 1, 2, 3. Positive x's is what we have left. All right, and that's equal to, I'm bringing down my equal sign. And what's left is 3 positive 1s. I want to figure out how much each of these x's is equal to. So I'm going to split these up evenly. So I have 3 of them. I'm going to give 1 to each one of those x's. So now we can see each x is equal to 1. Each one of these x's is equal to 1. So my final answer is x is equal to a positive 1. And that's it.
And example 3 here. The directions say model and solve the equation using algebra tiles. So here you'll notice that we have some grouping happening here. So remember, this is 3 of that quantity that's happening. So go ahead and pause the video, take a moment to model and solve, and then we'll go ahead and check it in just a minute. And here is our solution for example 3.
All right, here is our last solution for today's practice problems, example number 3. We're going to solve this equation using our algebra tiles. Again, we have the same key over on the left-hand side. All right, so let's take a look at what we have. We have 3 times the quantity x plus 2 minus 5 equals 7. All right, so let's talk about this first. So what this means is that we have 3 sets of x plus 2. All right, so x plus 2 looks like this. So we have a positive 1x plus 2 all right, so that's x plus 2, but we have 3 sets of that x plus 2. So I need 2 more sets of the x plus 2. All right, and I'm going to put my third x over here. And my other 2 over here. All right, and if you think about it, when we get into solving these algebraically with the distributive property, this is 3 times x, that's 3x, and then 3 times 2 is positive 6. 3 sets of x plus 2. All right, then we have minus 5, so that is 5 negative 1s, because negative 1 added together 5 times is negative 5. So I have 1, 2, 3, 4, 5. All right, 5 negative 1s minus 5. And that's going to be equal to 7 positive 1s. So there is my equation modeled. Now we need to look to see if we can create any zero pairs. So on my left side, I have 5 negative ones and I have 6 positive ones. So I can cancel out 5 positive ones with 5 negative ones to create a zero pair. So what's left is the 3 x's and a positive 1. And on my right side, I just have positive 7. So there's nothing to cancel there. There are only positives. So I'm going to bring down what I have left over. So I have 3x plus 1 equals, and we still have positive 7 on the right side. All right. So when we're solving equations, we're always trying to get that single positive variable by itself. So we need to ask ourselves what's attached to it. So what's attached to it is 2 other positive variables and a positive 1. So we're always going to get rid of that constant first. So the opposite of positive 1 is negative 1. So I'm going to add a negative 1 here in order to cancel that out. What I do on one side of my equation, I must do on the other. All right, create zero pairs if we can. So positive 1 and negative 1, that's 0. On the right side, we also have a positive 1 and a negative 1 is 0. So what we're left with is 3x equals 6. All right, so I need to figure out how many or how much each one of these x's is worth. So I'm going to flip my x's on their sides. I'm not winning any art contests here today. All right, so 3x equals, and on the right side, I have 6 positive 1s. So I need to evenly split those 6 positive 1s between my 3 x's. So I'm going to pass them out one at a time. So there's 1 for that x, 1 for that x, 1 for that x, that's 3, 4, 5, 6 of them. So each one of my x's is equal to 2 positive 1s. All right, so my final answer is 1x, positive 1x, which means that variable is isolated, is equal to positive 1.
That covers our examples today. So let's go ahead and take a look at your individual practice and homework. Again, please show and keep your work so that we can discuss your problems at the beginning of tomorrow's lessons. For this one, you are going to model and solve the following equation using algebra tiles. So you have 4x plus 4 minus 2x equals 8. And the second one here, it says, using the given key, write a multi-step linear equation to represent the model, then solve and confirm your algebraic solution. So remember, looking at your key there, here this key is a little bit different. You have your light colored box unit is just positive 1, your dark box is negative 1, and then you have your positive x and your negative x there. And as always, please log into Dreambox and complete at least one lesson today. You can go ahead and click the link here and log in through Clever. Thanks for joining us today on day 2. Tomorrow we will talk more about solving multi-step linear equations, and we look forward to hearing from you again soon.